So good morning students. So in that class we are going to discuss determine the Z transform of x of n minus a power n into u of minus n minus 1. So then determine the condition when the DTFT of x of n exists. So here the formula is x of z which is equal to summation n which is equal to minus infinity to minus 1 into minus a power n into z power minus 1 which is equal to, so minus of summation m which is equal to 1 to infinity a power minus m into z power m which is equal to minus summation m which is equal to 1 to infinity into a power minus 1 z the whole power m. Similar to example 5.1, so the x of z converges if modulus of a power minus 1 is into z less than 1 or modulus of z less than modulus of a. So which aligns the ROC for x of minus z, so which gives the formula x of z which is equal to minus summation m which is equal to 1 to infinity a power minus 1 z power the whole power m which is equal to a inverse z into 1 minus a minus 1 z in the in whole power infinity divided by 1 minus a minus 1 into z, and which is equal to a minus z divided by 1 minus a into 1 a power minus 1 into z which is equal to z divided by 1 minus a. So together with ROC the transform of x of n which is equal to minus a power n into u of minus n minus 1 and x of z which is equal to modulus of z z divided by z minus a, or modulus of z less than modulus of a means. So this is a formula for the previous condition x of z which is equal to z divided by z minus a, where modulus of z less than modulus of a, so that we can substitute instead of z which is equal to e power j omega we get, and x of e power j omega which is equal to e power j omega divided by e power j omega minus a, and modulus of e power j omega which is equal to 1 where modulus of a less than 1. As a result of the existing condition for DTFT where x of n is modulus of a greater than 1. So in Z plane we have a modulus of a less than 1 means the ROC lies between the interior part of the unit circle. So in the case of second one we have a Z plane and real and imaginary term, and we have a modulus of a greater than 1 means it is the interior part of the unit circle and exterior part of the Z plane. So this is a combination of ROC at both modulus of a greater than 1 and modulus of a less than 1. So ROC is for a modulus of a less than 1 and modulus of a greater than 1. So when x of n which is equal to minus a power n into u of minus n minus 1. And this slide shows the determine the transform of Z transform of x of n into a power n into u of n minus b power n into u of minus n minus 1, where modulus of a less than, here we have a two pole where z is equal to a and z is equal to b. So employing the results in example 4.1 and 5.1 and 5.2 we have the formula modulus of z which is equal to 1 divided by 1 minus a into z power minus 1 and plus 1 divided by 1 minus b into z power minus 1, where modulus of z greater than a and modulus of z greater than b. It means modulus of z greater than a like less than a lies between greater than a and less than b. So this is the condition. So from that we can apply the condition to obtain a minus b into z power minus 1 divided by 1 minus a into z power minus 1 into 1 minus b into z power minus 1, right? So the next step is a minus b. We can take the LCM of both sides and cancelling the things. A minus b, the a z inverse divided by a minus a into z inverse and a minus b into z inverse. A minus b is z divided by z minus a into z minus b, which is equal to modulus of a less than z modulus of x mean a z modulus of less than modulus of b. So note that the ROC agrees with figure 4.2. Determine the z transform of x of n into del of n plus 1. Using this formula x of z, we have a modulus of n which is equal to minus n into plus infinity, del of n plus 1 into minus infinity which is equal to z, and x of each transformation and transform of x of n which has the form of x of n which is equal to a power n into n lies between 0 lies between n minus 1 and which is equal to 0 otherwise. Using f5.1 we have a x of z which is equal to summation n which is equal to n minus 1 modulus of a z the whole power 1 minus n which is equal to 1 minus a into z power minus 1 into n divided by 1 minus a into z power minus 1 which is equal to 1 divided by 2 into n minus 1. That is z which is equal to n minus 1 into minus n divided by z minus a. So this was the condition. So how you can obtaining the expression means, in first unit we have studied causal and non-causal signals. According to that, this signal will be obtained using this formula. And finite duration and infinite duration sequence. Finite duration sequence values of x of n are non-zero only for a finite time interval. So this is for finite time interval. Time interval we have here finite time interval and infinite time interval, isn't it? So here x of n non-zero by only a finite timing variable. So otherwise if it is called an infinite duration sequence. So we have a finite duration in this property, but other cases the infinite duration is there and x of n is called infinite duration we can mention. And the left side sequence, right side sequence, two side sequence, like that we have three sequence. If x of n is equal to 0 for n less than n lies greater than n lies between infinity example x of n is equal to a power n into u of n when n which is equal to 0 and a which is equal to x of n which is equal to a power n to u of minus n or u of minus 10. And n which is equal to 10 x of n which is equal to a power n into u of n plus 10 into n plus which is equal to minus 10 volt. So if it is positive means the opposite sign will be negative. If it is negative means it will be positive. Okay. So left side sequence means if x of n which is equal to 0 for n lies between modulus of n lies between less than n and greater than minus n. So where n is an integer, example x of n which is equal to 0, a power n into n, u of n minus 1 which with n which is equal to minus 1, and x of n which is equal to minus a power u of n into u of minus 1 for 4 with the n which is equal to 10. Left sided. So if it is left sided means if a this figure shows the finite duration sequence. So in this case we have a modulus of a greater than 0, less than 0 and less than infinity and greater than 0. So in that diagram shows the ROC of n modulus of z less than a greater than a and modulus of z lies between a to b. So a means exterior part, interior part. So both the z plane called the finite and infinite duration. So here we have a 3 diagram. So in that x of n in x axis, in y axis, n in x axis, and the equivalent corresponding first case the ROC is exterior part of the unit circle, next case interior part of the unit circle, and the third one is interior and exterior, both causal and anticicle signal.